want to learn how to use spreadsheets and start analyzing data using Excel. This course from IBM is designed to help you work with Excel and gives you a good grounding in the cleaning and analyzing of data, which are important parts of the skill set required to become a data analyst. You will not only learn data analysis techniques using spreadsheets, but also practice using multiple hands-on labs throughout the course. In Module 1, you will learn about the basics of spreadsheets, including spreadsheet terminology, the interface, and navigating around worksheets and workbooks. In Module 2, you will learn about selecting data, entering and editing data, copying and autofilling data, formatting data, and using functions and formulas. In Module 3, you will learn about cleaning and wrangling data using a spreadsheet, including the fundamentals of data quality and data privacy, removing duplicated and inaccurate data, removing empty rows, removing data inconsistencies and white spaces, and using the flash fill and text-to-columns features. In Module 4, you will learn about analyzing data using spreadsheets, including filtering data, sorting data, using common data analysis functions, creating and using pivot tables, and creating and using slicers and timelines. At the end of this course, in Module 5, you will complete a series of hands-on labs which will guide you on how to create your first deliverable as a data analyst. This will involve you understanding what the business scenario is, cleaning and preparing your data, and analyzing your data. You will follow 2 different business scenarios throughout the course, with each using their own data set. These different scenarios and data sets will be used in the lesson videos and in the hands-on labs. After completing this course, you will be able to understand how spreadsheets can be used as a data analysis tool, understand when to use spreadsheets as a data analysis tool and their limitations, create a spreadsheet and explain its basic functionality, perform data wrangling and data cleaning tasks using Excel, analyze data using filter, sort, and pivot table features within Excel spreadsheets. You will also perform some intermediate level data wrangling and data analysis tasks to address a business scenario. The course team and other peers are available to help in the course discussion forums in case you require any assistance. Let's get started with your next video where you will get an introduction to spreadsheets. In this first video of the course, we will list some of the common spreadsheet applications available, learn about key capabilities of spreadsheets, and discuss why spreadsheets might be a useful tool for a data analyst. There are several spreadsheet applications available in the marketplace. Some of them are more widely known and used than others, and some are free, while others need to be paid for. By far, the most commonly used spreadsheet application, and the most fully featured of them all, is Microsoft Excel. The desktop version comes in a paid form as part of the Office suite and some Microsoft 365 subscriptions. But there is also a web-based cut-down version called Excel for the Web, also known as Excel Online. The online version is free to users with a Microsoft account, but does not offer all the advanced features that the desktop version provides. The next most popular is Google Sheets, which offers a lot, though not all, of the features that Excel provides, and is free with a Google account. This is a web-based application, and it integrates nicely with other Google apps, such as Google Forms, Google Analytics, and Google Data Studio. Then there is LibreOffice Calc, a totally free and open-source desktop spreadsheet application that offers more basic functionality than Excel or Google Sheets, but still has a lot of the tools you need for data analysis, such as charts, conditional formatting, and pivot tables. Other spreadsheet apps include Zoho Sheet, a fully featured web-based application that is comparable with Google Sheets, OpenOffice Calc, Quip for Salesforce, Smartsheet, which is predominantly for project management, and Apple Numbers, which is included with Apple devices such as Mac computers and is also available on the App Store for other Apple devices. So there are many spreadsheet application options open to you, from fully featured to basic, from cloud-based to desktop apps, from paid-for to free versions. It's up to you to decide which one fits your needs and your budget. Spreadsheets provide several advantages over manual calculation methods. For example, once you have your formulas correctly written, you can be assured that your calculations are accurate and that the calculations will be performed automatically for you. Spreadsheets also help keep your data organized and easily accessible. Your data can be easily formatted, filtered, and sorted to suit your needs. If you do make mistakes in your data entry or your calculations, you can easily edit them, undo them, or use error-checking tools to help remedy those mistakes. And lastly, you can analyze data in spreadsheets and create charts, graphs, and reports to help visualize your data analysis. Since spreadsheet software for personal computers first appeared on the market in the 1970s with VisiCalc on the Apple II PC, spreadsheets have come a long way in terms of the capabilities and features they now offer businesses. From uncomplicated tables and relatively simple computations to powerful tools for analysis, management, and visualization of enormous sets of data. The most common business uses for spreadsheet applications include the following: data entry and storage, comparing large data sets, modeling and planning, charting, identifying trends, flowcharts for business processes, tracking business sales, financial forecasting, statistical analysis, profit and loss accounting, budgeting, forensic auditing, payroll and tax reporting, invoicing, and scheduling. And away from the business side of things, other typical uses include personal expenses, household budgeting, recipe library, fitness tracking, calorie counting and weight monitoring, sports leagues such as fantasy football, cataloging music libraries, and even contact lists, shopping lists, and Christmas card lists. As a data analyst, you can use spreadsheets as a tool for your data analysis tasks, including collecting and harvesting data from one or more distributed and different sources, cleaning data to remove duplicates, inaccuracies, errors, and resolve missing values to improve the quality of the data, analyzing data by filtering, sorting, and interpreting it to determine what useful information can be gleaned from it, and visualizing data to help you tell a story about your data analysis findings to key business stakeholders and any other interested parties within your organization. In this video, we had an introduction to spreadsheets. We learned about some common spreadsheet applications, what the main capabilities of spreadsheets are, and why spreadsheets might be a useful tool for a data analyst. In the next video, we will look at the basics of spreadsheets, including common spreadsheet terminology. Now that we have a basic understanding of what spreadsheet software is available and why spreadsheets might be a useful tool for a data analyst, let's get started on looking at some of the basics of using a spreadsheet application. In these videos, we will be using the full desktop version of Excel, but the majority of the tasks that we will perform can also be done using Excel Online and other spreadsheet applications such as Google Sheets. Let's first cover some basic spreadsheet terminology. When you open Excel, you have the option of creating a new blank workbook or opening an existing workbook. We're going to choose New and then Blank Workbook. Workbooks are the highest level component in Excel and are represented as a .xlsx file. So when you open an existing workbook or create a new workbook, you are in fact working with a .xlsx file. The workbook contains all your data, calculations, and functions, and contains several other underlying elements that make up a workbook. A workbook consists of one or more worksheets, each of which is represented by a tab in Excel. Each worksheet is given a name which is displayed on the corresponding tab for the worksheet. By default, each tab is named Sheet 1, then Sheet 2, and so on. To make these worksheet tabs more meaningful, it is usual to rename them so they make more sense in relation to the worksheet's purpose. For example, you might call a worksheet January Sales, or perhaps the name of a region or store, or even an office or department. To do this, right-click the tab and choose Rename. Instead of right-clicking to rename, you can also just double-click the name of a worksheet tab to rename it. Essentially, worksheet tabs can be named anything you want to fit your particular needs to make it easier to understand what that worksheet represents. Note that a worksheet that is highlighted, as the Tire Sales Worksheet tab is here, is referred to as the active worksheet. If you want to order your worksheets in a different way, that is very simple to do. Either drag a worksheet tab to the left or right and drop it in the place you want, which is represented by the little black arrow. Or if you are not comfortable with dragging and dropping, then the longer way of doing that is to right-click the worksheet tab, select Move or Copy, and then in the list titled Before Sheet, select where you want your worksheet tab to be placed and click OK. Every worksheet is made up of a lot of rectangular boxes called cells. These cells will contain your data, which may be text, numbers, formulas, or calculation results. Cells are organized in columns, which run vertically down the screen and use a letter system. This is column B, for instance. And rows, which run horizontally across the screen and use a numeric system. This is row 7, for example. Each cell is represented by a cell reference, which is essentially just a column letter and row number. For example, if we click somewhere near the center of this worksheet, we now have the cell M20 selected. This is usually referred to as the active cell. This is not only indicated by the highlighted edges of the cell, but also if you look in the top left corner of the worksheet, you will see its cell reference is noted in the little box. Here you can see it says M20. One important thing to note here is that cells are always referenced by their column letter first, then their row number. So column M and row 20. The last element of a workbook I want to mention is a cell range. This identifies a collection of several cells selected together that could mean a few cells in the same row or the same column, or it could mean several rows and columns together. This can either be done using the mouse by selecting the first cell, then dragging down or across to include other cells, or you can use Shift plus arrow keys. This range of cells is often referred to as an array, and it's most commonly used as a reference in calculations and formulas. For example, if you want to add up all the values in a column between cells D9 and D19, you would specify this cell range within a formula. Note that cell ranges are notated using a full colon between the cell references. So in this example, it would be D9 colon D19. Or to specify a few cells in the same row, it might be D9 colon H9. Or to select several rows and columns, it might be D9 colon H19. We will see this notation in use later in the course when we start looking at calculations and formulas. These cell ranges could even be a reference point to cells contained on another worksheet. This is usually referred to as a 3D reference. We can now close this workbook and we don't need to save it. In this video, we learned about some of the basic terminology of spreadsheet elements. In the next video, we will discuss how to navigate around a spreadsheet, how to use the ribbon and menus, and how to select data. Now that we have a basic understanding of the main elements that make up a worksheet, let's see how to move around a spreadsheet, get familiar with the ribbon and menus, and learn how to select data in a worksheet. To open a sample file, we click File. This opens Backstage View. Here you can create a new workbook, or open, save, or print a workbook. You can also access Excel options. Now we want to open our sample file, so we click Open and either select it from My Recent list or click Browse to find the data file we want. The first thing we should do is get acquainted with the ribbon and menus. Notice that on the ribbon at the top we have several tabs. Some of these tabs may be familiar to you with other Office products, such as the Home, Insert, and View tabs, while others might be new to you, such as Formulas, Data, and Power Pivot. To make a little more workspace for ourselves, we can hide this ribbon by double-clicking any tab, and to unhide it, we do the same. The other option is to use the shortcut key, Control plus F1. The ribbon is organized into groups of buttons to make them easier to find. So on the Home tab, we have groups for font, alignment, number, styles, and so on. Some of these groups contain all the available buttons on the ribbon when viewing in full screen, such as styles and cells, but other ribbon groups have more options, which we access by clicking the little arrow icon in the bottom right corner of the group, as can be seen here on the number group, for example. The next item I want to point out is the Quick Access toolbar at the top of the screen above the ribbon. As the name suggests, this is where you can quickly access the tools you use most often. You can see we already have some tools in this toolbar, such as Save, Undo, Redo, New, and Open. But we can add other tools to the toolbar if we wish. So if we click the drop-down arrow in the toolbar and then select a tool we use a lot, such as Sort Ascending, that will be added. And we will also add the Sort Descending button. Now we need to be comfortable with moving around a worksheet. You can simply use the arrow keys to move left, right, up, and down one cell at a time. But you can also use page down and page up to move around a bit faster, which is especially useful if you have lots of rows of data. And to move even quicker up or down a large data sheet, use the vertical scroll bar. And to move left or right, use the horizontal scroll bar. Again, these can be very useful when you have a large data set. There are also some useful shortcuts you can use. Control plus Home key, for example, takes you back to the start of the worksheet, that is, cell A1. Control plus End takes you to the cell at the end of your data in the worksheet. Control plus Down arrow takes you to the end of the column you're in, while Control plus Up arrow takes you back to the top of that column. So a quick way to find out how many rows of data you have in your worksheet is to go to the first cell in your data and press Control plus Down arrow to see the last row of data. So here you can see we have 160 rows. Now, how do we go back to the top again? Control plus Home will do it. So far, we have seen how to navigate around our worksheet and its data. Now we need to look at how we select data. This is very important because you often need to select data to move it, copy it, or select it in a formula. The simplest selection is a single cell, usually done with a mouse or maybe a directional arrow key. The next step up is to select multiple cells together, and this can be done either with a mouse by dragging from one cell to additional adjoining cells, or you can use the Shift key with directional arrow keys. Next up is selecting a single column or row, which is done simply by selecting the letter at the top of the column or the number on the left of a row. Then we can progress to selecting multiple columns and rows by clicking the mouse button, holding it down, and dragging across more columns. Or if you are not comfortable with dragging, you can also select the column first, then hold Shift plus arrow keys to select multiple columns. The same applies to rows too. However, if you have data in non-continuous rows or columns, that is, not next to each other, you can select the first column, then use the Control key to select another unconnected column, such as columns C and F here. The largest thing you might want to select is the whole worksheet, which you can do by clicking in the top left corner of the cells. However, this selects the entire worksheet, including all the empty rows and columns. So if you only want the data in your worksheet, you can use the shortcut Control plus A. A word of warning when selecting data in cells, rows, and columns. There are 3 types of cross symbols that you might see when working with selected cells. The first one is the large white cross that you see when you select a cell, as can be seen here in cell A4. This is the select cross that we have been using already in this video to select cells. The second type you might see is when you hover over the bottom edge of a cell and see a thin black cross-type symbol with arrows on each point. This is the move symbol and would move the cell data to another location. The last type is the small thin black cross that is seen when you hover over the bottom right corner of a cell. This is the fill handle or copy symbol, and it fills or copies the cell data to another location. In this video, we learned how to move around a spreadsheet, become familiar with the ribbon and menus, and learned how to select data in a worksheet. In the next videos, we will discuss how to enter data, how to copy and paste data, and how to format data in a spreadsheet. In this video, we will listen to several data professionals discuss the advantages and limitations of using spreadsheets as a tool for data analysis. Let us start with, what are the benefits and advantages of using spreadsheets as a tool for data analysis?
My experience using spreadsheets as a tool for data analysis is somewhat mixed. I think they can be really useful in the right context, but using spreadsheets definitely has its limitations. So the big pro of using spreadsheets is you can see all the data cleanly laid out in front of you in a table. So I think it's very clear to anyone looking at a spreadsheet exactly what the data is, what format it comes in, all of that. You can just easily visually inspect it.
As a CPA, I use Microsoft Excel on a daily basis, and I have done so for the duration of my career. The functionalities, the pivot tables, the charts, etc., but also being able to use formulas. My personal favorite is index match for using a pretty simple way to take just thousands of lines of information and sift through all of that to find specifically what you're looking for. Excel is really that one-stop shop where you can perform calculations, analyze financial ratios, and even export reports out of the ERP that I spoke of earlier to customize it as you need.
My experience is using spreadsheets is that they're great for simple analysis.
I will say spreadsheets over the years, the process itself has just improved. As systems improve, as technology improves, spreadsheets are the way to go. Spreadsheets overall, when you do have probably anywhere from 0 to 20,000 lines of data, it's a good way to go. You can really pull out the data, whether I'm trying to see how much a client's making per month, but they may have 1,000 transactions. All of that's helpful. I can use this spreadsheet to whittle down what is actually going on per month, or if I want to do a sum if, or if this happens, give me this number. It's really helpful to be able to dig in and wrap your hands around it and take something that seems on the surface, 20,000 lines seems almost unmanageable. But if I take it and I massage it, put it in a spreadsheet, and then sort it, filter it, make it pretty, put it in a pivot table, I can get what I need. It's just all about not looking at it as being this intimidating thing, but making it more manageable and breaking it down into bite-sized chunks.
Spreadsheets are the easiest way to analyze data and present data. We don't need any fancy tools or additional software for spreadsheets. It's like the commonly utilized language to communicate.
Thank you for that insight. But let's move on to look at the other side of the coin. What are the drawbacks and limitations of using spreadsheets as a tool for data analysis?
I think one of the big cons in terms of analyzing data within spreadsheets is it's really hard to reproduce state. So in other words, if you load in some data and you filter out some bad values, or you impute some missing values, there's no way to tell your colleagues or your future self exactly the different steps you took to create that data set or to modify that data set.
It's almost a dilemma because of the plethora of options available within Excel and all of the functions that are there supposedly to make your life easier, but it's nearly impossible to know everything. And you can find yourself in what we accountants call analysis paralysis when you're looking at something for too long, or you're not well versed in a particular Excel function. So you may spend a lot more time, energy, and effort trying to figure that one thing out. And had you done it a different way, or maybe a manual way, you probably could have gotten to the solution a lot easier.
And the downside of using spreadsheets is that if you have complex formulas, VLOOKUPs, if statements, at times they just stop working and you have to rebuild them. So I have found that it's better to use Excel just for simple analysis and for a download of information.
I love a good spreadsheet. I love using Excel and pivot tables to get to the data. But I find that if I start to get over 10, 20,000 lines of data, it gets a little tricky. And sometimes the spreadsheets will crash. So that's when we might move to Access and some of the other tools that we use.
It's very difficult to handle the extremely large data set in spreadsheet. Besides, spreadsheet has less flexibility for complicated analysis and presentation.
Now that you have learned basic spreadsheet terminology and how to navigate your way around worksheets and select data in Excel, it's now time to start entering some data. First, we will look at some of the handy viewing features provided in Excel, and then we'll enter some data, and then we'll edit that data. When you have a lot of data in your worksheet, it can be useful to zoom in closer to a specific area of the data. The zoom slider at the bottom right corner of the worksheet allows you to do just that. You can either click on the plus and minus buttons or drag the slider to select your preferred zoom value. You also have some zoom controls in the ribbon on the View tab. Zoom lets you pick a predefined zoom level or a custom one. The 100% button zooms the worksheet back to its original size, and Zoom to Selection enables you to select an area of data and then zoom into that specific selection only. If you want to see several areas of your data at the same time while zoomed in, you can use the Split button. This splits the screen into multiple sections, and you can scroll each section separately. If you only want 2 sections, you can remove either the horizontal or the vertical split by double-clicking on it. If you have headings in your columns, like a header row, then you might want those to remain on screen while you move down the sheet. To do that, you need to use Freeze Panes. You can freeze only the top row if you wish, or if that doesn't suit, as is the case here, then you can select the row or even just a cell in the row below the row or rows you want to freeze, and then select Freeze Panes. You can do a similar thing for columns if you want to freeze them too. And you can even freeze both rows and columns at the same time. The trick here is to first select the cell that is both one row below where you want to freeze and one column to the right of where you want to freeze. In this case, that is cell C4. Now we can scroll down the worksheet and across the worksheet, and we can still see the header row and the manufacturer and model columns. Now, if you have multiple workbooks open, notice I said workbooks and not worksheets, then you can switch between them by using View, Switch Windows, or the faster method is to use the Ctrl plus F6 shortcut. Now let's enter some data into our blank worksheet. The easiest way to open a new worksheet from within Excel is to click the New button in the Quick Access toolbar, or Ctrl plus N if you prefer keyboard shortcuts. So let's enter some headings across the top of the worksheet. This is typically referred to as a header row. Note that if you press Enter after typing data into a cell, the next active cell is the one directly below, which is not what we want in this case. But if we press Tab after we enter data in a cell, it selects the next cell along in the row as the active cell. Now we'll enter some headings and press Tab after each entry. Notice that the text is slightly longer in some of the cells, and it either gets partly hidden by the next cell or overlaps it. If you click and hold the divider line between two columns, you can drag it left and right to resize it manually. If you want to do that automatically, you can double-click the divider line between two columns. As these are going to be headings for our columns, let's make them bold. Now let's add another column between the Parts and Accessories column. Simply select the right hand of those two columns, then right-click and choose Insert to put another column to the left of the selected column. Let's call it Servicing Sales. To tidy up our column width simultaneously, we select all the columns from A to E, then double-click any of the divider lines between columns. This automatically reduces or increases each column's width to fit the data in that column. Okay, now we have some headings. Let's enter some month data in column A. So, if we type Jan in cell A2 and press Enter, then it takes us to the cell below, which is what we want in this case. And we can type Feb in cell A3, and so on, until we get to December in A13. Now let's suppose you need to change a couple of your headings. You have several ways of editing existing data in a cell. You can either select the cell and then just start over typing, or you can select the cell and press F2 on your keyboard to put the cursor at the end of the cell and make your changes. Or you can simply double-click somewhere on the cell and put the cursor at that position in the cell and make your changes. And you can even select the cell and then click in the formula bar to edit your cell data. Now let's do the same for the Parts and Accessories column headings. In this video, we learned about some of the viewing options in Excel, and we learned how to enter and edit data in cells. In the next video, we will learn how to copy and fill data and how to format the cells and data in a worksheet. Now that we have learned about some of the handy viewing features provided in Excel and entered and edited some data, let's discuss how to move, copy, and fill data and how to format cells and data to suit our needs. The first thing we are going to discuss is how to move data. So if you select a range of cells, in this case the headings in A1 to E1, and then hover over the top or bottom edge of a selected cell, you will see the Move pointer. Then you can drag the selection to another place on the worksheet. Alternatively, if you want to copy the data instead, you do the same thing, but this time you also hold Control key as you select and drag the selection to another location, and you will see the Copy pointer. If you are not comfortable with dragging, you can also use Copy and Paste menu commands or keyboard shortcuts. If you select some data in column A and copy it to the clipboard, then you simply select the new location and paste the copied data. You can also move or copy between worksheets. So let's create a new worksheet. Then select some data from Sheet 1, and this time let's use the Ctrl+C keyboard shortcut to copy it to the clipboard. Then choose the other worksheet and use the Ctrl+V shortcut to paste the data. However, notice that the column widths are not the same as the original source data, so let's undo that and try another paste option. By default, when you paste the copied data, it uses the column width settings of the destination cells. So, to paste it and retain the column widths of the source data, you choose the special option under the Paste command, called Keep Source Column Widths. As an alternative to having to enter data manually in a worksheet, you can use an Excel feature that automatically fills cells with data when it follows a sequential series or pattern. The feature is called Autofill, and it can be especially useful when you need to enter lots of repetitive data into Excel, such as date information. For example, if you enter a month in a cell, even using a shortened version of the name, you can use what's called the fill handle to select down to the end of the series, and autofill will work out what the series is based on the selected data. Let's try the same thing with days of the week. If you enter Mon for Monday in a cell, then drag the fill handle to use autofill, it will determine that you want to enter the days of the week sequentially. However, if you also enter Wend for Wednesday in the next cell down and select both cells in the series, that is A16 and A17, and then drag the fill handle down, autofill determines that the sequence has changed to every other day and fills in the data series for you. It's important to select all the cells that determine the pattern when using autofill so that it can best determine what the pattern is, in this case, cells A16 and A17. A similar thing applies to numerical patterns. If you enter 5 in a cell and then use the fill handle to fill the data down the column, because the data is not the name of a day or month, for example, autofill can't determine what the pattern is yet. So in this case, it just copies the value 5 into every selected cell. However, if you enter the value 10 in B3 and then use the fill handle to fill data down the column, autofill determines that the pattern is incrementing by 5 each time, and it fills in the remainder of the data pattern for you. Now we're going to look at formatting our data, and there are essentially 2 distinct parts to this. First, there's formatting of the cells themselves, with a fill color and a bold border, for example, and bold text within it. And then there's formatting the data in the cells, for example, making it text format, number format, or a specific currency or accounting format. Let's open the car sales worksheet we used previously. Then select the headings in cell A3 to P3, either using the mouse or you could use the shortcut keys Ctrl plus Shift plus right arrow. On the Home tab, click the Styles drop-down arrow and then select a style color for your cells. Then you can make the selected cells bold. Then you select the data in the manufacturer column, either using the mouse or the shortcut keys Ctrl plus Shift plus down arrow. In the Styles drop-down arrow, select another style color for the selected cells. Again, you can make the cells bold. Then you select the data in the model column again, either using the mouse or the shortcut keys Ctrl plus Shift plus down arrow. In the Styles drop-down arrow, select another style color for the selected cells. This time you can make the selected cells italic. And you can also change the font size and style. Lastly, you can select all the other cells in the data by using the mouse or the Ctrl plus Shift plus right arrow, then down arrow, and apply borders to the data cells. Now it's time to format the cell data. The sales figures in columns C and D can be formatted to display only one decimal place. Just select the data and click the Decrease Decimal button. We also have an issue with a couple of the car models. If you look in cells B129 and B130, where the model name is supposed to be displayed, you can see there are actually 2 dates listed instead. And if you look in the number format box, the format type is custom. This has happened because the model numbers are supposed to be the Saab 9.5 and the Saab 9.3. But when the files were imported from CSV files, these 2 cells must have been incorrectly determined to be date values and not just numbers. You can fix this by formatting these 2 cells as text and then enter the correct values of 9.5 and 9.3. The last thing we want to do is format some data as currency. If you look at the heading in column F, it says it is price in thousands of dollars, and cell F4 is using the general format. So let's change the format of this column to American currency format. We select the column, F in this case, then select More Number Formats from the drop-down list. Then we choose the currency option and the correct currency symbol and format, and we're done. In this video, we learned how to move, copy, and fill data, and how to format cells and cell data to suit our needs. In the next video, we will look at the basics of formulas, learn how to perform simple calculations, and learn how to select ranges and copy formulas. Now that we have learned how to move, copy, and fill data, and how to format cells and data, next we will take a look at the basics of formulas, including some basic calculations, selecting ranges in formulas, and how to copy formulas. A typical formula is made of several key components. The equal sign starts the formula off and lets Excel know you are creating a formula in this cell. The next part is the function, which performs the calculation. For example, the sum function adds up the values in referenced cells or cell ranges. Then comes the reference, which is the cell or range of cells you want to include in your calculation, and these need to be enclosed in parentheses. You also have operators, which specify what type of calculation to perform. Common arithmetic operators include addition, subtraction, multiplication, and division, and these are represented by symbols: the plus symbol for addition, the minus symbol for subtraction, the asterisk for multiplication, and the / for division. There are other types of operators too, namely comparison, text concatenation, and reference. You may also use constants in your formulas, which, as the name suggests, are numbers or values which you can enter directly into a formula, and which don't change. This might be a whole number, such as 5, it might be a percentage, such as 10%, or it might even be a date. So a typical formula might be =sum, open parenthesis, B5, asterisk, 20, close parenthesis, which would take the value in cell B5 and multiply it by 20. Let's start with a few basic calculations. Suppose you want to add up January and February sales of accessories. You would start by typing an equal sign, which lets Excel know you are entering a formula. Then you type in the function you wish to use, in this case, the sum function. Note the description. Next, you type an open parenthesis. Then you select your cell range, which in this case would be E2 to E3. So you could enter that as E2, E3, then a close parenthesis, and press Enter. And if you wanted to add March sales as well, then you would have to extend the cell range to include E4. So you could type E2, E3, E4 as your range, and it will work. Remember, to edit a cell, you select the cell and either edit it directly in the formula bar or press F2 or double-click the cell. However, it's very cumbersome and not very flexible to do it this way, because if you wanted to add up the entire column, then you'd have to type every cell reference, one after the other. So thankfully, there's a better way. Instead of typing each cell to include in the reference, you just put a colon between the first and last values in our range. So E2, E4 in this case. And if you wanted the whole column, then you would enter E2, E13 in your formula. But there's another way of doing it, and that's by using your mouse to select the range, so you still type =sum, then open parenthesis, but select the range with your mouse or Shift plus arrow keys, and just press Enter. Excel will add the close parenthesis for you. To total these columns up and add some tax, you'll add some headings first for subtotals and tax at 20%. Then your formula will need to multiply the value in subtotals by 20%. If you wanted to add up all the column subtotals and calculate the taxes, then you would repeat the previous process for each column. But that's very time-consuming and you don't need to, because Excel has some neat tricks to do this for you. Just select the fill handle in the bottom right corner of the cell and drag across to the other cells to copy the formula. This is called autofill. Notice how the formula is copied, but the row references change in relation to the cell's position on the worksheet. So what was E2, E13 has become B2, B13. These are known as relative references, but more on that later in the course. And you can do the same thing for the tax values in row 16. Now, you need a row for showing the totals. The calculation here is simple. The subtotal value in cell B15 added to the tax in B16. And again, you can use the fill handle to copy the formula across. If you wanted to total the sales of all products by month, you'd add a column heading. Notice how the cell style is copied to the new heading automatically. Remember, to widen a column, either drag the divider manually or double-click the divider. Then, enter the formula in cell F2 as you've done before. However, Excel has another trick up its sleeve. It's called AutoSum and is found on the Home tab in the Editing group. This is a great little shortcut for some simple common functions like sum, average, count, max, and min, but you can choose other functions too. You want sum for this particular calculation. Notice that it also has a keyboard shortcut of Alt plus equals, and then press Enter and it's done. Now you can use the fill handle to copy down the remaining values. But hold on, there is one more Excel trick to show, and it's a good one. Suppose your column of data was very long. You might have to drag the fill handle down over several pages, which isn't easy to do and can easily lead to errors when selecting large lists of data values. Rather than needing to drag down to the rest of the column, you can just double-click the fill handle and it will automatically copy the formula to all the remaining cells in that column. This one is a real time saver. Finally, let's format all these values to use the US dollar currency format. In this video, we learned about the basics of formulas, how to perform simple calculations, how to select ranges in formulas, and how to copy formulas. In the next video, we will look at how to use some of the common functions used by data analysts and discover some more advanced functions. Now that you have learned about the basics of formulas, learned how to perform some basic calculations, and how to select ranges and copy formulas, next we will have an introduction to functions, including using some common statistical functions, and then we will learn about some more advanced functions that a data analyst might also use. First, let's look at some common functions used for statistical calculations. We'll add some row headings for average, minimum, maximum, count, and median. Then, in cell B20, let's work out the average of the car sales for the year from the table above. On the Home tab in the Editing group, we click on the AutoSum drop-down list and choose Average. Now, because AutoSum tries to add up the values directly above it in the column, we need to modify the cell range here to B2 to B13. Then we can use the fill handle, as we've seen before, to copy the formula across to column E. For the minimum calculation in B21, we select min from the AutoSum list. And again, we need to modify the cell range, so this calculates the lowest value in our range. And fill across to column E, and for the maximum calculation, we select max from the list, and then modify the range. And once again, copy the formula across. This calculates the highest value in our range. In B23, we will calculate the count, which basically just means the number of values that exist in the selected range. So we select count numbers from the list, then modify the range. For the median calculation, we can select more functions from the AutoSum list, then select statistical as the category, and scroll down to find the median function. The median returns the exact middle of a range of selected values. Note that if you're selecting an odd number of values, it will return the figure that is the middle value in your selected range. But if you have selected an even number of values in your range, it will return the middle figure between the two middle values in your range. Once again, we need to change the cell range to B2 to B13. And we can then copy this formula across to column E. You've seen AutoSum and some of the common statistical functions in Excel, but there are another 400 plus other functions available. So let's explore just a few of those now. On the Formulas tab in the Function Library group, there are drop-down lists for several function categories. The first is a list of recently used functions, which updates automatically as you use them. Then you have functions related to financial calculations. If you hover over the name of a function, you see a short description for each one. So here we have the accrued interest function, and here is the interest rate function. The logical list has Boolean operator functions such as and, if, and or. There are several functions related to text, such as concat, which is an updated version of a previous function called concatenate, which is still supported, by the way, for backwards compatibility, find, and search. There are also several functions related to dates and times, such as net workdays, weekday, and weeknum. In the lookup and reference list, there are functions such as areas, HLOOKUP, sort by, and VLOOKUP. In the math and trig list, you'll find lots of useful mathematical functions, such as power, SUMIF, and SUMPRODUCT, alongside many functions for trigonometric purposes, such as cosine, sine, and tangent. There is also a More Functions list, which provides several more function categories, such as statistical, engineering, and information. In the statistical list, you'll find functions such as average, count, max, median, and min. We saw some of these used earlier in this video. If you're struggling to find the function you want in these lists, you can also search for a function. Just click the Insert Function button on the Formulas tab, and then either browse the category lists available or choose All and look down the alphabetical list for the function you want. Alternatively, type the name of a function you want and click Go to search for it, then select the one you want from the returned search. In this video, we learned about the basics of functions, how to use some of the more common functions that a data analyst might employ, and looked at some of the more advanced functions available in Excel. In the next video, we will look at referencing data in formulas, specifically differentiating between relative and absolute references, and error handling in formulas. Data analysis can play a pivotal role in business decisions and processes. In order to use the data to make confident decisions, we must have the right information for the project, and the data must be free from errors. In this video, we will learn how to profile data to discover inconsistencies. Whether we are working with small sets of data or analyzing a spreadsheet with thousands of rows, one of the most difficult parts of the data analysis is finding and keeping clean data. To help with this process and qualify the data, look at these 5 traits: accuracy, completeness, reliability, relevance, and timeliness. Accuracy is the first and most significant aspect to data quality. A data analyst must clean the dataset by removing duplicates, correcting formatting errors, and removing blank rows. Another important aspect of data quality is determining if the information required to complete the dataset is readily available. Why does this matter as a trait for quality data? Let's say we are given the task to calculate the revenues of all sales per region. After collecting the data, we discover that no regions were specified. This data would then be considered incomplete, and other sources would have to be considered to obtain the data required. Reliability is another vital factor in determining the quality of data. For instance, let's say we are given the task to determine the agent revenue by customer. When gathering the data, we find that agents keep their own records and do not always update the information in the shared company database. With those factors in mind, we would then determine that the data in the shared company database was unreliable, and new processes would need to be established to ensure reliable data. Relevance is another trait of quality data. When collecting information, a data analyst must consider if the data being assembled is really necessary for the project. For example, when reviewing the data related to the sales revenue per customer, information such as customer birthdays and other personal information is also included. By making the determination early to exclude the personal information from the dataset, the analyst would save themselves from having to review unnecessary information. The last factor in determining the quality of the data is timeliness. This trait refers to the availability and accessibility of the selected data. Let's say our sales report is going to be used for weekly employee reviews, but our report is only refreshed once a month. This error in refreshing the data would cause our report to become outdated and would have serious consequences for employee reviews. In this video, we learn the important role of a data analyst in qualifying data. By considering the 5 traits of good quality data, an analyst can save time, avoid serious issues, and have data that is free from errors. In the next video, we will take the collected data and learn how to import it to our spreadsheet. Now that you have learned about the importance of data quality, in this video you will learn how to import data from a text file using the Text Import Wizard, learn how to adjust column widths, and learn how to add and remove columns and rows. As you know, by default, Excel works with .xlsx or .xls files and opens them as workbooks. But Excel can also use data that is in other formats, such as plain text, or data that has been comma separated and tab separated. Sometimes these source files will be saved with a .txt extension and referred to as text files, but others might be saved with a .csv file extension and are typically referred to as CSV files. Here in Notepad, I have opened a text file that contains data about car sales, and it uses comma-separated values, or CSVs, to separate each bit of data in a record. Notice that the top line holds headings, such as manufacturer, model, engine size, and so on, and each one is separated by a comma. We want these to become our headers when we import the file into Excel. The line below these headings is the first line of real data, and again, you can see that each piece of data is also separated by a comma. There are 16 headings, and there are also 16 pieces of data on each of the lines below the headings. If we scroll to the bottom, we can see that last data record is for the Volvo S80. Now, to open the file in Excel, we choose File, Open, and then either select the file from the recently used list or click Browse to find the file we want to import. When we open the file, the Text Import Wizard launches automatically, and it will start to try and determine what your file is. Note that it has been detected as being a delimited file, that is, one that has its data fields separated by a character such as a comma or a tab. As we want the headings to become headers in Excel, we need to ensure that we select the option My Data Has Headers. We can see a mini preview of the data in the preview box below. Then we click Next to proceed in the wizard. In step 2 of the wizard, we need to select our delimiter, that is, which character is separating our pieces of data, so we select comma and deselect any others. Note the data preview now starts to show us what the imported data will look like. You can scroll down and across this preview window to ensure that the data is going to look as you want and expect. It all looks okay, so we'll continue with the wizard. In step 3 of the wizard, we can set the data format for each column. For example, you might want to change a column to text or date format. In this case, we can just accept the default general format and finish the import wizard. In Excel, we can see that the headings in the text file have been imported as a header row. But also notice that some of the columns are not showing all the data. Some of the headings are not showing in full, and some of the data is not shown either. all you can see are a number of hashes in the cells. This is because the column widths are too narrow in some cases. If you remember, you can manually adjust a column's width by dragging the divider across, but to change them all in one go, we select all the columns first, then double-click one of the selected column dividers. We can also do a similar thing with rows by dragging them to make them bigger or smaller, or double-clicking a row divider to auto-size it. There are some columns that we have decided we don't really need, namely vehicle type and latest launch. So let's remove those. This can either be done using the Delete drop-down menu in the Cells group on the Home tab and select Delete Sheet Columns, or by selecting and right-clicking a column and deleting it that way. To add another column, you simply select the column to the right of where you want your new column to be. Then right-click the column and choose Insert. And let's give the header a name, such as Year. To delete a row you don't need, select the row, right-click it, and choose Delete. And to add a row, select the row below the place you want to add your new row, right-click the row, and choose Insert. If you want to save the file as an Excel file, you can either choose File, Save As, or you can click Save As in the yellow tooltip that appeared at the top of the worksheet when we imported the file. Then you would choose Excel Workbook or .xlsx in the Save As type box. In this video, we learned how to import data using the Text Import Wizard. We learned how to adjust column widths, and we learned how to add and remove columns and rows. In the next video, we will discuss the importance of data privacy, including sensitive information and personally identifiable data. In this video, we will learn about data privacy and the regulations that govern the collected data. When collecting customer data, specific regulations apply to how that data can be used. By understanding data privacy regulations and getting familiar with the following 3 fundamentals, you can eliminate the risk of financial penalties and keep the trust of your customers. Confidentiality, collection and use, compliance. Confidentiality is an important element in data privacy, and it acknowledges that the customer's personal information belongs to them. The types of information that can be accessed by a data analyst can range from sales forecasts to employee information, or even patient records. When accessing these types of records, the analyst must be able to recognize the different types of personal data. Personal information, or PI, is any type of information that can be traced back to a specific individual. This type of information can include anything from emails to images. Personally identifiable information, or PII, is specific information that could be used to identify an individual. This type of information could include a social security number or a driver's license number. And lastly, sensitive personal information, or SPI, may not necessarily identify a specific individual, but contains private information that needs to be protected because, if made public, it could possibly be used to harm the individual. This type of information can include data about race, sexual orientation, biometric, or genetic information. By understanding personal data and the associated regulations, we can efficiently anonymize our data by removing unnecessary information. This type of action can help build customer confidence and continue to develop the free flow of information. When searching through data, the analyst must know the location of the company collecting the data and the location of the respondent. Knowing where the data was collected is an essential element of data privacy and what regulations must be applied. The General Data Protection Regulation, or GDPR, is a regulation specific to the European Union and only applies to the jurisdiction of the individual. A new law created in Brazil, called the LGPD, will take effect in August 2020. These new data policy regulations apply to individuals within Brazil and ignores the location of the data processor. While the United States does not have one countrywide principal law for data privacy, because of this, individual states began to make their own regulations. For instance, California created the California Consumer Privacy Act, or CCPA, to better protect customer data. There are also industry-specific regulations that govern the collection and use of sensitive and personal data. For example, in healthcare, HIPAA, or HIPAA, privacy rules govern the collection and disclosure of protected health information. In retail, the PCI standards govern credit card data, and failure to safeguard cardholder information can result in hefty fines. With a basic understanding of these policies, we are able to remain compliant when handling any sensitive information. Unfortunately, breaches in customer data is an all too common occurrence, and understanding how to remain compliant is essential. Understanding the data privacy regulations of the European Union, the United States, and other countries as well as industries is key to keeping data safe. Companies must comply with these privacy regulations at all times, and also make sure policies are readily accessible to employees. For example, let's say a data analyst downloads a spreadsheet of sensitive information. In order to complete the report by Monday morning, the analyst decided to take their work laptop home for the weekend. After driving home, the analyst accidentally left the laptop in their car. The next morning, they found their car had been stolen along with the laptop. Because it is the responsibility of the company to keep customer data safe, this was a breach of privacy when the data left the company property. This type of action could not only cost the company large amounts of money in fines and penalties, but could also reduce customer confidence, causing a significant impact to revenue. While data privacy applies to most data that is collected, there are some instances where these regulations do not apply. In order for these laws and regulations not to apply, the particular collection of data must be completely anonymous. To make data anonymous means to exclude all data which ties it back to a particular individual. While this approach might not be practical in all circumstances, collecting data with privacy in mind could remove privacy limitations and make data collections more accessible. In this video, we learned about the importance of data privacy and the challenges that a data analyst can face when collecting and sorting through data. In the videos in the next lesson, we will learn about different methods for cleaning data in a spreadsheet. In this video, we will listen to several data professionals discuss the importance of data quality and data privacy as they relate to data analysis. Let us start with what is the importance of data quality as it relates to data analysis.
Data quality is of the utmost importance in terms of data and analytics. And the reason behind this is because as soon as what you're presenting does not align with what someone expects, that's the first thing that they tend to go after. Where did you get the data? What's happened to the data? How has it been transformed? Because people like to think that they know and understand their business. And when you start to challenge that, if you don't have the ground to stand on of the data, that it's quality, that it's clean, and that it is from a trusted source, that's when you start to get into a lot of discussions, a lot of debate, and ultimately the plot of what you're trying to present gets lost.
The backbone of any successful data analysis project is good quality data. There's a common term in computer science called garbage in, garbage out, which is essentially if you read in bad quality data, you can expect to get bad quality results. So there's really nothing more important when doing a data analysis than making sure that you're working with good quality data. And it's really important to sense check the data yourself and really feel comfortable that the data you're using is of a really high quality.
Data accuracy is above all, garbage in, garbage out. It's a waste of time to analyze data of poor quality, and it might mislead the business direction.
The integrity of the data that you're using or providing for someone else to use is of the utmost importance. Data is used to determine when or where to launch a product, if a division is profitable or not, and it's easy to get things confused if you're not paying attention to the details. Using inventory as an example, if you're looking at inventory at a SKU level and you accidentally pick the wrong SKU to analyze, and then you draw these conclusions that this particular item isn't profitable when in fact it is. So that's a major decision for a company to make, obviously. So the expectation is that there will be lots of due diligence, but in the beginning, if you start off with bad data and then you build on that only to later realize that it wasn't a good idea, you've lost time, energy, effort, and in some cases, trust.
Thank you for those viewpoints. What about the importance of data privacy as it relates to data analysis?
Data privacy is incredibly important, especially when you're working in industries like pharmaceuticals or healthcare. But that's not where it stops. We have to have the ability to make sure that the users are getting the appropriate level of data based on their roles and their permissions. Now we can do this through a number of cuts of the data specific to each geography or each function, or in some tools such as Cognos Analytics, we can start to build out that as part of our model. Within there, you can say who has access to what, whether it's at a granular level of this person can see data in Canada or the US, or whether it's simply this person can see this report in its entirety or not. There's lots of different ways to handle this, but data privacy is of the utmost importance across all industries.
In today's world, data privacy is a huge thing. On the tax side, especially of our business, we have what we call PII, personal identifiable information. We have to protect that, and so we can't just send things through email. We don't send tax returns, or even actually in our business period, we don't send things through email that have sensitive PII data in it. We encrypt it. We make sure the email is encrypted, or we use software, some certain softwares that will allow us to not show the social security numbers or the names or the date of births. And what will happen is it has a certain sequence, and we share that with the client by calling them. We don't put that in an email, and we certainly don't put that in the same email with the encrypted information, because we want to make sure that you're always safe. So we have to make sure we're protecting it at all costs.
Now that we have learned about the importance of data quality and data privacy, in this video we will learn how to deal with inaccurate data, how to remove empty rows, and how to remove duplicated data. It's very common when collecting or importing data, whether through manual or automated processes, to get errors and inconsistencies in your data. This can be as simple as spelling mistakes, extra white space, or the wrong case used in text, to empty rows or missing values in your data, to inaccurate or duplicated data. Having these errors and inconsistencies in your data can lead to issues with formulas not working, with unsuccessful sorting and filtering operations, and therefore inadequately visualized and presented data findings. These data errors and inconsistencies require you to carry out some form of data cleaning routine to improve the quality and usability of the data. Let's start off with one of the easier of those tasks, which is spell checking. In Excel, this works in pretty much the same way as you may have already encountered in applications such as Microsoft Word or other common word processing applications. I have some data here relating to the sales of toy vehicles, and the first thing we need to do is select what data we wish to check for spelling. In this case, we will try column K, which contains the product line data. Then we click Spelling, which is on the Review tab. Well, that seems to be okay, so let's try the country information in column T. So we do have an error here where a country name has been misspelt, or more likely, mistyped. We just click Change if we are happy with the spelling suggestion, or we could choose another suggestion from the list, or even ignore this error if we know the data is correct, but in this case, we will change it. Here's another typo for a country name. And here's one more. So that seems to be all the errors in this column. Let's try the final column now, which is the DL size in column X. Here's a misspelling of the word small and another for medium. And that seems to be all for this column. The next inconsistency we will look for is empty rows. Empty rows in your data can cause lots of issues relating to moving around your data, working with formulas, and sorting and filtering. Therefore, it's very important to remove them from your data. If you remember from an earlier lesson, when we click Control plus down arrow, it should take us to the end of that column of data. But notice if we do that in this data set, the cursor keeps stopping when we get to an empty row, meaning that the data set is essentially being split into multiple sections, separated by these empty rows. That's not good, so let's resolve that now. We have a couple of options. One option is to just manually scroll down the sheet looking for empty rows and deleting each one, which is easy enough and fine to do if you only have a small amount of data. But imagine if you were dealing with hundreds or thousands or even tens of thousands of rows. That would be a very laborious and time-consuming process. There is a much better way, which involves selecting all our data first, either using the mouse or the Control plus Shift plus End keyboard shortcut. Then we select the filter icon on the Data tab. We can now see that each column has a filter icon next to the column header. If we then select the customer name column filter in column M, then uncheck Select All, then scroll down to the bottom of the list, we can check the item called Blanks, and then click OK. This will now show only the empty rows at the top of our sheet. This can be quite hard to see, but if you look in the row numbers, you can see that rows 28, 29, 65, 73, 74, 75, and 117 are listed at the top and are highlighted in blue text. We can now select these rows either using the mouse or going to the first cell in the first data row, which is A28, and then using the Control plus Shift plus End keyboard shortcut. Then delete the offending empty rows. We then need to clear the filter and turn it off so we can view our data again. Now, if we go back to the first row in the top of the data sheet and try the Control plus down shortcut again to go to the end of the data column, it will work. The next inconsistency we'll look for is duplicated rows of data. It's quite common for duplicate data rows to exist in your imported data, caused either by human input error or an error in the import process. There are two ways of doing this in Excel. The first way includes reviewing the data you plan to remove first, before deleting it, to ensure you are deleting the right data. This is our preferred method as it provides an additional level of data security. The second method, which we will also show you, is simpler, as you don't review the data to be removed first, but it lacks the security of the first method. It's important to select a column of data that you would not expect to have duplicate values in. For example, if we consider the price each column, which is C, we would expect lots of these values to be repeated because the unit price of some products is the same. So this is a bad example of a column to use to find duplicates. Instead, let's use the sales column in column E because it is far less likely that these values will be duplicated in the normal process of things, as they are the total sales for each order. So we select the column and choose Conditional Formatting, then highlight Cells Rules, and then Duplicate Values. When we click OK and scroll down the sheet, we can see that only a few values have been identified as being duplicates. There seem to be duplicate values in rows 36 to 40 and in rows 74 to 78. Let's zoom out so we can see both duplicate sections together. It seems like these are in fact exact duplicate entries and are likely to be an input error. Let's delete the second section of duplicate rows as they are out of sequence, as they relate to motorcycle sales and are in the ships section of the sheet. So that was the first and recommended method of removing duplicate rows of data, which previews the data to be removed first. Now, let's try the second, simpler but less secure method. Let's go back to 100% zoom and go back to the top of the worksheet. This time, we select the whole data sheet, and on the Data tab, we use the Remove Duplicates button. We then unselect all the columns, then only select the Sales column, and the duplicate rows are deleted. The last cleaning process we'll look at in this video is using the Find and Replace feature to repair some misspelt surnames in the Customer Contacts column. Find and Replace tools are under Find and Select on the home page in Excel. If you have used other Office products such as Word, it should be familiar to you already. We've had an email from a Swedish customer informing us that we have her surname spelled incorrectly on her order sheets. So we type the misspelled surname into the Find What box and click Find Next. Then click it again to see there are multiple incorrect entries. If we click Find All instances are listed, and we can open the Replace tab to enter a name to replace the incorrect spellings. Her surname should be Larson with a double S, so we'll replace all instances with that corrected spelling. That looks better, and we are finished. In this video, we learned how to deal with inaccurate data, how to remove empty rows, and how to remove duplicated data. In the next video, we will look at changing the case of text, fixing date formatting errors, and trimming whitespace from data. Now that we've learned how to deal with inaccurate data, how to remove empty rows, and how to remove duplicated rows, in this video we'll look at changing the case of text, fixing date formatting errors, and trimming whitespace from data. When you collect or receive data from various sources, it's quite common to find that your data contains text in mixed case, that is, some in uppercase, some in lowercase, and some in capitalized proper case, also known as sentence case. Some of this may be intentional, but often it's not. Excel doesn't have a change case button like there is in Microsoft Word, so you need to use other methods to perform this data cleaning task. Those methods are functions, namely the upper, lower, and proper functions. You can use these functions to help you change the case of text in your data. You can see that the header row here is using all uppercase characters. So if you want to change that to use proper case, then you need to add another row to put the function in. This is referred to as a helper row. The proper function is simple to use. Just type equals, then proper, then open parenthesis, then the cell reference, in this case A1, then close parenthesis, and press enter. Here you can see that the result in A2 is in proper case. Now you can try and drag the formula right across to column X by using the fill handle on A2, but this can be tricky when you have a lot of columns, so let's try another way. Instead of dragging, you can use Shift plus right arrow to select the columns across to X first. Then press F2 to bring the cursor into focus in cell A2. Then you hold down the Control key while you press Enter, and it fills across for you. You might think that you could now remove the original row, but look at what happens when you do. You get a ref error because the formula is referencing an invalid reference, and the header row cells now contain just the failed formula rather than the actual header text. So you need to undo that, and instead, you copy the contents of the helper row to row 1. But when you paste, you need to choose the Paste Values option. Now the header row cells just contain header text, and you can remove the helper row in row 2. Now let's use the upper function to change text from proper case to uppercase. Insert a column to the right of the column you want to change. This will be a helper column. Then you type the formula containing the upper function in the first data cell in this new helper column. Again, it's a simple formula. You type equals, then upper, then open parenthesis, then the cell reference, in this case T2, and then close the parenthesis and press enter. You can see the result in the country name in uppercase, and you can then copy that formula down the rest of the column by double-clicking the fill handle cross symbol. As before, you then copy and paste the contents of the helper column to the original column, but use the Paste Values option. Now you can delete the helper column. Next, we'll use the lower function to change text from propercase to lowercase. As before, you insert a column to the right of the column you want to change. This will be another helper column. Then, you type the formula containing the lower function in the first data cell in the helper column. Once again, it's a very simple formula. You type equals, then lower, then open parenthesis, then the cell reference, in this case K2, and then close parenthesis and press enter. You can now see the result is the product line data in lowercase, and you can now copy the formula down to the rest of the column by double-clicking the fill handle once more. As before, you then copy and paste the contents of the helper column to the original column by ensuring you use the Paste Values option. Now you can delete the helper column. It's quite common to receive data that has a mixture of date formats, or that uses a date format that isn't suitable for your region. Now let's look at how to change the format of some dates. You can see that this date format is currently using a 2-digit day, a 2-digit month, and a 4-digit year value. When you open the number format dialog box, you can see in the locale box that this is an English or United Kingdom date format. You want to use a US date format, so you first change the locale to English, United States. In this list, you can see there are several date options to choose from. Let's choose one that uses the full month name, then a 2-digit day and a 4-digit year value. You could then copy this formula to the rest of the date cells. However, if you want to format these dates using your own custom format, you can do that too. In the number format list, you select Custom and then choose an existing format that is similar to what you want, and simply modify it to create a new custom format. Here we'll have the day, then 3-letter month, then 4-digit year. To apply that new custom date format to the rest of the column, you could either use the Format Painter tool, or you can select the rest of the column and choose the new column format from the custom list in the number format dialog box. You might find that your data has some white space, that is, unwanted spaces in your data. Here you can see that we have some spaces at the start, some spaces at the end, and some unwanted double spaces in the middle of our data. We'll first have a look at what you can do to clean up these unwanted spaces in your data by using the Find and Replace feature in Excel. So you first select all the data, then on the Home tab, you click Find and select, then Replace. To get rid of double spaces, you enter a double space in the Find What box and a single space in the Replace With box. Then you click Find Next and choose Replace for each item you want to change. You could click Replace All to do all the fixes in one go, but unless you are absolutely sure of the changes, it's better practice to check and replace each one in sequence in case there are some valid reasons for these extra spaces. If you have a very large data set, you might also choose Replace All to save you a lot of time. So using the Find and Replace feature got rid of most of those unwanted white spaces, but not all of them. We removed double spaces using that feature, but we also have some single spaces left at the start and end of some of the cells. You can't use Find and Replace to remove single spaces. Otherwise, you would lose all spaces in your data, including standard spaces between words, which you don't want to remove. But there is another tool you can use to clear spaces from cells, and that's the Trim function. To use the Trim function, you once again insert a helper column. The Trim function is simple to use. Just type equals, then trim, then open parenthesis, then the cell reference, in this case, M2, then close parenthesis and press enter. You can then double-click the fill handle symbol to copy this formula down to the remainder of the column. Now, you need to copy the contents of the new column N to column M, and remember once again to paste using the Paste Values option. You can now see that those erroneous spaces have been removed, or more accurately speaking, have been trimmed. And lastly, you can remove the helper column. In this video, we learned how to change the case of text, how to change date formatting, and how to trim white space from data. In the next video, we will discuss how to use the flash fill and text to columns features in Excel to help clean data. Now that we've learned how to change the case of text, how to change date formatting, and how to trim white space from data, in this video we'll discuss how to use the flash fill and text to columns features in Excel to help clean data. We used flash fill briefly earlier in the course as a quick method of entering data that fits a specific pattern, such as the names of months or days of the week, but it can also be used as a data cleaning tool. It can split a column of full names into two separate columns for the forename and surname, and it can also help to modify the naming convention used in a column of names. For example, in the Vehicle Toy Sales worksheet, there is a column containing the last names of contacts and another containing their first names. If you want to use the flash fill feature to combine these names into one name column, you first insert a helper column. Let's call it Contact Name. Then, in the first row in the new column, you enter the full name of the first contact in the format of your choice. For example, you might want surname, then a comma, then the forename. Or you might want surname and just an initial, and so on. In this case, let's just enter the name in the standard format of forename, then surname, with a space between them, and then we press Enter. Next, you'll start typing the second contact's name, and you'll see that Flash Fill displays a preview of the remaining names for you. If you're happy with what's in the preview, all you have to do is press Enter, and it fills in the remaining names for you right down the column. It even works when there are two names in one of the columns, such as Wing C here and Dakuna here. Now you can remove the original columns if you no longer need them. So in the previous task, we saw how to combine two columns of data into one column using flash fill. Now let's see how to use it to modify the naming convention in a column. Let's switch to the Customer Contacts worksheet. Then, in the first data row of the next column, that is B2, we type the name of the first contact using whatever naming convention we want. We'll use surname, then comma, then space, then the forename, and press Enter. Again, when we start typing the second contact's name in the next row down, that is B3, Flash Fill detects the pattern and fills in the remaining names in column B when we press Enter. You could then copy and paste the column header and delete the original column A. What we couldn't do with Flash Fill was take a single column with two names in and split that into two separate columns. We need to use the Text to Columns feature to do that. So we'll close this worksheet and we won't save the changes. Now let's see how the Text to Columns feature can help with data cleaning too. As the name suggests, and unlike Flash Fill, the Text to Columns feature can take a column containing multi-part text and split that text into one or more other columns. This can be useful for splitting any multi-part text, such as names or addresses, into separate component parts. Let's open the Customer Contacts worksheet again. Then we'll add column headings for the next two columns and copy the cell format used in the first column header. Then we'll widen the columns. If we then select the data in column A from A2 to A23, and on the Data tab click Text to Columns, a wizard is launched. On the first page of the wizard, ensure that Delimited is selected. On the second page, ensure that only Space is selected as the delimiter. On the third page of the wizard, click the little arrow next to Destination and select B2 on the worksheet, then click the little arrow again to return to the wizard. We're now finished with this wizard. You can now see that the full customer contact names in column A have now been successfully split into two new columns in B and C, and you could now remove column A if you no longer need it. We'll close this worksheet, and again, we won't save the changes. You can also achieve the same result using functions. This would be required if you were using Excel for the web, the online version of Excel, as this doesn't have the text to columns feature. There's also a bit more flexibility with functions, which can be especially useful if you have names that are complex and mixed, such as having hyphenated names, or some names with a middle name, some with 2 middle initials, and some with no middle initial. So we open the Customer Contacts worksheet again. Then we'll add column headings for the next 2 columns and copy the cell format used in the first column header. Then we'll widen the columns. Next, we'll enter the formula in B2 to extract the forename part of the name. This formula extracts 5 characters from cell A2, starting from the left and including the space. Then, in cell C2, we enter the formula to extract the surname part of the name. This formula extracts 7 characters from cell A2, starting from the right. Then we'll double-click the fill handle in cell B2 to use autofill to complete the column. And we do the same to the fill handle in cell C2 to use autofill to complete that column also. In this video, we learned how to use flash fill and text-to-columns features in Excel to help clean data. In this video, we will listen to several data professionals discuss issues around data quality. Can you tell us your experience with poor quality data and the cleaning of that data?
A large portion of my time is spent cleaning, verifying, checking data before I run an analysis. Working in healthcare, most of the information captured is based off of what someone's put in. So humans can't be calibrated. 2 people can have a similar situation and look at things slightly differently. So it's up to me to make sure that if one describes something as navy blue and the other person describes it as dark blue, that I consolidate it and make it blue. That's just an example. We don't normally do that in healthcare. But the thought is that you always have to check the integrity of the information before you do your analysis to make sure that your results are accurate.
No data is going to be perfect. That's an unfortunate reality in the world in which we live in. Databases and data is collected for the broadest possible purpose, but oftentimes there are still things that are missing or not quite in the format that we want, whether that's collecting date and time as a single field, whereas when we're doing our analysis, we want to be able to break it out by day, month, and quarter. These are things that we can take into consideration. There's a lot of different cleansing activities that can be done and can be undertaken to help you get something that's specific and works for you and the way you want to work.
I have had experiences with poor quality data where I'm reviewing financial statements and I'm looking at margins, calculating ratios, trying to understand if what I'm looking at is, number one, directionally correct, but 2, am I looking at the right thing? Are all of these costs, current costs, relevant to the period that I'm analyzing? Has all of the data been captured? Do I have all of the revenue for a given month? Then you have to go back and look at the sources, scrub that information to validate that what you're seeing is correct. And from an accounting perspective, if that data is incorrect or out of period, then adjustments need to be made to the general ledger, which houses the data to properly reflect what's happening.
Poor data quality can really come into play and cause discussions that don't need to be happening. They can cause you to be second guessed. They can cause you to not be able to be firm and present your case and your data reliably. Now, if this is the case, there's several different ways you can handle this. One is to go all the way back to the source to ensure that the source data is being pulled appropriately, or simply being able to outline and be very specific and direct in terms of what transformations or changes have been done to the data through tracking this in something like Watson Knowledge Catalog and being able to present that to your audience.
If you're filtering and sorting data and you find that it's wrong, you have to go back and fix things. That time could have been spent working on other deliverables. And again, it can call the data integrity into question if you're constantly having to redo or reiterate certain parts of data. And quite frankly, it can be frustrating at times if you're habitually having to do that. So paying attention to the details and the minutia so that you're not wasting time backtracking on something that you could have fixed early on are just some of the many benefits of ensuring that your data quality is good.
Now that we have learned how to collect and clean our data, it is time to decide the best method for analysis. In this video, we will discuss the importance of filtering, sorting, performing calculations, and shaping our data to provide meaningful information. Deciding how to manipulate our data can sometimes be difficult. Before we make any changes or adjustments, we will need to visualize the final output. Below are some questions to ask before beginning the task. How big is the data set? What type of filtering is required to find the necessary information? How should the data be sorted? What type of calculations are needed? Now that we have visualized the final output, we must decide the best approach to shape our data. The most basic step would be to filter and sort the data. By sorting the data, we are able to organize it based on conditions, such as alphabetically or numerically. For example, if we wanted to check for duplicate order numbers, we could sort the data and quickly see any duplicates. After sorting and removing the duplicate row, we find that the view needs to be more specific to meet our requirements. We now decide that we only want to see the data for the month of November. By adding a filter, we can now choose to only see items with a month ID that is equal to 11. By filtering our data, we are now able to only see the rows that meet the filter criteria, and it allows us to better analyze our information. Becoming familiar with all the tools to analyze data can seem daunting, but one key benefit of using a spreadsheet is the ability to use functions. Functions in Excel are organized by several categories, including mathematical, statistical, logical, financial, and date and time-based. Let's say we wanted to get an average of company revenue for the month of June. We realize there are over 100 items that would need to be calculated. In normal circumstances, to get an average, we would have to create a formula to add each row and divide by the total number of rows. This type of calculation would not only be very long, but can expose the analyst to possibly making a mistake. With the use of a function, we would be able to simplify our calculation in one easy step. Equals average, open parenthesis, B1, colon, B160, close parenthesis. While sorting and filtering data on our spreadsheet can be useful on its own, first converting your data to a table has many benefits. When we convert our data into a table, we are able to filter and calculate the data more efficiently. One example is the ability to easily calculate columns. For the column MSRP, we choose Sum, and we're able to quickly calculate the sum of the column. If we then look at the data, and we only want to calculate the MSRP total based on Japan, we would filter the country column to only display Japan, and the column would then only add the values in the rows that were associated with Japan. While all data may not work in a table, there are quite a few advantages to formatting your data as a table. Automatic calculations even when filtering. Column headings never disappear. Banded rows to make reading easier. Tables will automatically expand when adding new rows. Sometimes data needs to be more organized than what a basic tabular format can give us, and creating pivot tables with charts can be a better way to analyze and display the required information. In Excel, we have the option of creating a pivot table to display and analyze our data, and optionally, an associated pivot chart. For example, let's say we want to know what company ordered products in the month of October. From the original table of data, we create a pivot table to organize and analyze the required data, along with a pivot chart to display the information. By then adding the month filter to the newly created pivot table, we can see the results for the month of October not only in the table, but the changes are automatically updated in the pivot chart. When trying to single out specific information in a large data set, a pivot table is a nice way to show only the information that is required. This allows us to quickly and easily scan the essential information. Pivot charts are a nice accessory to pivot tables, as they allow us to visually process data and in most cases will let the audience grasp the information quicker. The advantages of selecting a pivot table and chart are: manipulate data without using formulas, quickly summarize large data sets, ability to display engaging charts and graphs. In this video, we learned about the importance of filtering, sorting, performing calculations, and shaping our data to provide meaningful information. And we learned about some of the tools to begin analyzing our data. In the next video, we will learn more about filtering and sorting our data. In the previous video, we learned how to use the flash fill and text-to-columns features in Excel to help clean data. In this video, we will discuss how to filter and sort our data to enable us to control what information is displayed and how it's displayed in our worksheets. Filtering your data enables you to gain more control over which parts of your data are displayed at any given time in Excel. This can help with the visibility of data by narrowing down the data to within specified criteria and parameters, and it can also help when searching for specific pieces of data. To filter your data, the first thing you need to do is turn filtering on, which is very simple. On the Data tab, click Filter, and that's it. You will now see a small filter icon next to each of the column headers. As a side note, if you want to only filter on one or more columns, select those columns first, then click Filter. As another side note, if you format your data as a table, the columns automatically have filter controls added to them. So now, each column has a filter that can be applied to the data in that column. In the Order Date column, you can filter on the years. In Product Line, you can filter on the different product types. And in Customer Name, you can filter on each customer by name. Let's first filter on the year. We'll select orders from 2004 only by deselecting the other year. And if you wanted to, we could expand the year and filter by months also, but we won't do that for now. If you look at the status bar at the bottom of the worksheet, you can see that there are only 50 out of 114 records now displayed. If you want to clear a filter, you can either click the Clear Filter From option or click the Select All item in the filter list. Now, let's filter on the Product Line column to display only the rows that hold data for sales of classic cars. And again, we'll clear the filter. Lastly, we'll filter on the Customer Name column and only display sales to Mini Gifts Distributors Limited. And then clear that filter. So far, we've only applied one filter at a time, but suppose you want to filter down to a greater degree. We can do that too by just enabling all those filters together. And now we are only displaying sales of classic cars to Mini Gifts Distributors Limited in 2004. Remember, if you only want to clear one filter, then click its filter button in the column header and click the Clear Filter From option. But if you want to quickly clear all filters, you can use the Clear button in the Sort and Filter group on the Data tab. So far, we've used what are commonly referred to as auto filters, but you can also use custom filters to specify other criteria to apply to a filter to text or numbers. For example, if you wanted to see sales orders that are over or under a certain value, you can do that with custom filters. For the sales column, let's add a number filter that only displays sales that are over $2,000. If you look in the status bar, you can see that we are now showing 111 out of 114 records. Then let's clear that filter and filter it the other way to display the sales orders that are below $2,000. We can see that there are only 3 orders that are below $2,000. It's important to note that the data rows that we don't see have not been removed. They are still there. They have just been hidden from view by the filters. And this is indicated by the row numbers you see on the left in blue. The row numbers start at 69 and jump in large increments, indicating that there are many more rows of data in our data set than are currently being displayed. Let's clear those filters. If we look at a column filter for a column that contains text, you will see that the menu item changes to text filters instead of number filters. And you can see that there are several text filter options. And if you want to turn off filtering altogether for a worksheet, just click the Filter button on the Data tab. Now let's take a look at the basic sorting capabilities in Excel. Sorting is a very important part of the role of a typical data analyst. You might need to organize your text-based data alphabetically, your number-based data numerically, or your date-based data chronologically. When you sort data using these logical parameters, it makes it easier for you to conceptualize and visualize your data in a more meaningful way. When sorting data, the first thing you need to do is select which data to sort. For example, if you want to sort your customers alphabetically, select a cell in the customer name column first, and then either sort by A to Z or by Z to A. And if you want to sort your sales figures numerically, select a cell in the sales column first, and then either sort from smallest to largest or from largest to smallest. And lastly, if you want to sort your customers' order dates chronologically, select a cell in the order date column first, then sort from oldest to newest or from newest to oldest. But you can also sort your data by more than one column at a time. Simply select a cell in your data, then on the Data tab, click Sort. Then either use the Sort by Column suggested or use the drop-down list to select a different column. In this case, we'll choose the Order Date column as our first sorting criteria, and we'll choose oldest to newest in the order drop-down list. To add a further sorting level, you click Add Level. Then you choose another sort column in the Then By drop-down list. In our case, we'll choose Sales, and for this sort level, we'll choose largest to smallest in the order list. If you have a header row in your data, as we do here, then ensure you select the My Data Has Headers checkbox, then click OK to sort. So, the data is now sorted to list the oldest orders by order date first, then within each order date, if there are multiple instances with the same order date. Then, the next sorting level lists data by the largest order values first, down to the smallest order values. In this video, we learned how to use the filter and sort tools in Excel to filter and sort our data to enable us to control what information is displayed and how it is displayed in our worksheets. In this video, we will listen to several data professionals discuss the importance of filtering and sorting your data. Why is it important to filter and sort your data?
Filtering and sorting are very important as part of your analysis and visualization experience, because this allows you to create one single view of the data, but then provide a function for people to be able to do their own analysis on it. Now, just to clarify, what we mean by this is sorting tends to be highest to lowest, alphabetical. Or in some cases, you may want to create some custom sorting where you put your particular product or offering at the start and then have the rest fall in behind it. Or you may want to group a few at the start to show your direct competitors versus others.
I love the filter and sort feature in Microsoft Excel. What it allows me to do is get to the heart of the data. I can drill down and see, for example, how much revenue a client had for a specific time frame or how much money they made in a specific time frame without looking through a lot of rows and a whole lot of information. So filtering and sorting really allows you to narrow it down and to get very specific and get the answers that you're looking for and not just get loads of data that you don't necessarily need.
Now, when we talk about filtering, we talk about this to mean that I have a particular value on which I want to see the data specified by. So for example, if we had a bar chart showing our sales over months, and I want to see it in a particular geography or for a particular product line, I could have that available and allow me to filter down so that my sales would be specific just to one geography or one product line.
Now that we've learned how to use the filter and sort tools in Excel to filter and sort our data to enable us to control what information is displayed and how it is displayed in our worksheets, in this video we'll discuss how to use some of the most common functions a data analyst might use, namely if, ifs, COUNTIF, and SUMIF. First up, let's look at how to use the if function. The if function is one of the most used logical functions in Excel. The if function enables you to logically compare a value against criteria you set in the function, and then return a result based on whether the result of the logical comparison is true or false. And these values can be text values or numeric values. An if function essentially says, if something is true, then return a value or do something. But if it's not true, then return a different value or do something else. For example, in our vehicle toy sales worksheet, if we wanted to have a column that recorded whether the order had been shipped or not, you could add a new column to the right of the existing column, let's call it shipped, and then enter the formula seen in cell H2. This formula is saying if the text in G2 says shipped, then return yes. And if it doesn't, then return no. You can then use the fill handle to copy this formula down the column. You can see that most of the cells do say yes, but some don't, as the order hasn't been shipped for one reason or another. We could also use the if function to emphasize the size of an order. So, if we add a new column to the right of sales and name it 3K plus or minus, then enter the formula seen in cell F2. This formula is saying if the order is over 3,000, then return the text over 3K. But if it isn't, then return the text under 3K. And we can copy the formula down the column. In an ideal world, you would only use the if function to apply one or two conditions, but there may be scenarios where you would want to apply multiple conditions. In these cases, you can use the nesting capabilities of functions to bring together several if statements in one formula. These are called nested if functions. For example, if we add another column here for the order size, and then enter the formula seen in cell F2, you can see that this formula contains multiple if functions. One is needed for each condition, one for large, one for medium, and one for small. And it requires 3 sets of parentheses. So it's a relatively long and complex formula, but it does work. Again, we can copy the formula down the column. Even though Excel technically supports the nesting of up to 64 different if functions in a formula, it is not a recommended best practice. Having multiple if functions in a singular formula can become extremely challenging to manage. For example, suppose you come across a formula like this that you haven't used for some time, or even worse, was created by someone else. it could be quite difficult to work out how and why it is being used. Also, if your conditions increase, then you need to add more conditions to an already quite complex and long formula, which will only complicate matters more. To resolve this issue, a new function was developed called ifs. The ifs function is only supported on Excel 2019, Excel for Microsoft 365, and Excel for the web. As the name suggests, this function can replace multiple nested if functions being used in a single formula to simplify matters. So, if we add a further column for order size, but this time we'll use the ifs function instead. As you can see in cell G2, this formula only has one set of parentheses instead of 3, and only uses one function instead of 3. Let's copy that formula down the column too. Now let's have a look at another example of using the if function, but we'll combine it with conditional formatting too. If we switch to the car sales worksheet and add a new column to the right of the year resale value column and call it retention percent, then we enter the formula seen in cell G2, which will divide the year resale value by the original retail price. We need to format this as a percentage, and then we can copy it down the column. Next, we'll add a column to highlight the retention value for each car. The formula we add here in cell H2 uses the if function to state that if the percentage in the previous column is greater than 69%, then mark it as good. But if it isn't, then mark it as poor. Once again, we copy the formula down the column. We could also use conditional formatting to highlight the retention value percentages even more. We select H2 and on the Home tab, click Conditional Formatting and make a new rule. The condition in our rule will only format cells that contain a specific text value, and that value is the word good. And if it does match that condition, then format it with a dark green font and fill the cell in pale green. Let's copy that conditional formatting down the rest of the column. You can see that the cells that contain the word good are now formatted as we defined, but the cells containing the word poor are not. Let's add another conditional format rule. This time, we'll select Manage Rules because we are going to add another rule to our existing rule. The new rule will be the same as the previous one, with the exception of looking for a match with the word poor instead, and formatting those matching cells with red text and a pink background fill. And once again, we copy that down the column. Now, all the cells that contain the word poor are formatted as red text with a pink cell fill. Let's now have a quick look at how to use the COUNTIF function. COUNTIF is one of the statistical functions provided in Excel. You can use it to count the number of cells that meet a certain criterion, such as the number of instances where an employee's name appears in a list of sales invoices, or the number of occasions a particular part number appears in a list of purchase orders. Let's switch to the vehicle toy sales worksheet. Suppose you want to find out how many of the sales orders in the list went to customers based in the United Kingdom. We enter the formula you see in cell AD7. Note that when we are using text as a criterion, we have to enclose the text in quotation marks. So there were 6 sales orders in the UK. And if you wanted to discover the same thing for French customers, then you would just edit the existing formula or copy it and then edit it. You can see there were 14 orders for French customers. Notice that this time the text entered was in lowercase, and it still works, so names in this function are not case sensitive. And let's do the same for United States customers. There are 41 orders to customers based in the States. There is also a newer function called COUNTIFs, which applies criterion to cells across multiple ranges to count the number of occasions where all criteria have been met. This removes the need to use multiple COUNTIF functions in a long and complex single formula. The COUNTIFs function is only supported on Excel 2019, Excel for Microsoft 365, and Excel for the web. Now let's take a look at how to use the SUMIF function, which is a very commonly used mathematical function in Excel. You use the SUMIF function to sum the values within a specified range that meet specified criteria. For example, you might want to add up only the salaries that are over a specified salary level, or you might want to find the total of all sales of a particular product category. We'll enter the formula seen in cell AD10. This formula will add up each of the sales orders that have a total of more than $3,000. Again, notice that because we have used an arithmetic operator, that is, the greater than operator, we must enclose the criterion in quotes. If we specify a criterion that is only a number, we don't enclose it in quotes. So, the total sum of all orders that were over $3,000 is almost $470,000. You can also use wildcards, such as question mark and asterisk, when searching for partial matches, and you can also specify to extract values from a different column than the column where you have specified the criteria. For example, if we enter the formula you can see in cell AD13, it will sum all the car sales in column E for only those products in the product line column that end in cars. There is also a newer function called SUMIFs that you can use to sum cells based on multiple criteria. This removes the need to use multiple SUMIF functions in a long and complex single formula. The SUMIFs function is only supported on Excel 2019, Excel for Microsoft 365, and Excel for the web. In this video, we learned how to use the if, ifs, COUNTIF, and SUMIF functions. In the next video, we'll look at how to use the VLOOKUP and HLOOKUP reference functions. Now that we've learned how to use the if, ifs, COUNTIF, and SUMIF functions, in this video we'll look at how to use the VLOOKUP and HLOOKUP reference functions. VLOOKUP is one of the most commonly used reference type functions in Excel, and it enables you to find data referenced in a lookup table. It stands for vertical lookup, and therefore is a useful tool when you want to find something in a table or a range by row. Shortly, we will look at HLOOKUP, which stands for horizontal lookup, which looks for data by column instead. VLOOKUP works by using a common shared key between the source data and the lookup data in the lookup table. A typical lookup formula would look like $VLOOKUP, open parentheses, B3, comma, A2, B12, comma 2, comma, false, close parentheses, where B3 is the lookup value, that is, the value or word you are looking for. A2, B12 is the lookup table or range, that is, the table array or range of cells that contains the lookup value. In a formula, Excel references this as table_array. The lookup table can be on the same worksheet or in another separate worksheet. 2 is the lookup column number, that is, the number of the column in the lookup table that contains the value you are looking for. In a formula, Excel references this as col_index_num. False is an optional parameter that determines whether the match found has to be exact, denoted by false, or can be approximate, denoted by true. In a formula, Excel references this as open square bracket, range_lookup, close square bracket. The square brackets around this argument in the formula signifies that it is an optional argument, whereas the others are required arguments of a VLOOKUP formula. If you don't specify the optional false or true parameter in your formula, it will default to false. That is, an exact match is required. You can also use the number 0 instead of false and the number 1 instead of true. Okay, now let's see the VLOOKUP function in action. In the car sales worksheet, suppose we wanted a quick price list of our favorite cars. The first thing we need to do is put the column containing the value we want to search for in the leftmost column, as VLOOKUP requires this. Then we can delete the original column. We then enter the formula seen in cell V16, which is looking for the word Corvette in the table array from cell A2 to G156, and then looks for the value in the 5th column, in this case, the price column, that matches the row containing Corvette and returns an exact value of $45,705. Note that in this example, we are using a part of our existing data table as the lookup table or table array. Let's format that as US currency. Then we'll format it to 0 decimal places. In fact, rather than use the reference A25 in the formula, it will be easier to use the reference to the word Corvette in the mini table in this worksheet where our list of favorite cars is. So that is V5, and the formula still works. Now let's copy that formula up to the favorite car table above it in the worksheet. But there's a problem, because when we copied the formula, the cell references changed. This happened because, as we learned earlier in this course, the default state of cell references is relative, and we want them to be absolute in this case. So let's undo that copy operation. To make the cell references absolute, we need to add dollar symbols to all the cell references in the formula. This can either be done manually, or you can put the cursor in each cell reference in turn in the formula and press F4 each time to automatically add the dollar symbols. Let's try and copy the formula again, and this time it works. If we use the fill handle on cell W5 to copy it down to the rest of the cars, it doesn't work. In fact, we end up with the same result in every cell. Why? Because each one is referencing the same cells in the lookup value, because we used an absolute reference. All we need to do now is modify the formula to remove the absolute reference for just the row parameter in the lookup value part of the formula by removing the dollar symbol. So in cell W5, we change $V$5 to $V5, comma. Then, when we drag the fill handle down, it will copy the formula correctly, and all the prices will be changed to reflect their correct retail price. Lastly, to show that the two tables are now connected by this VLOOKUP function, if we change the retail price for the Chevrolet Corvette in the main data table in cell E25, the price will also change in the favorite car's price list. Let's now take a look at the HLOOKUP function, which, as we mentioned earlier, does the same thing and works in virtually the same way as the VLOOKUP function, but it looks for data in columns rather than rows. So, HLOOKUP looks for a word or value in the top row of a table, and then returns a value in the same column from a row specified in the table array. Therefore, you would use HLOOKUP if your comparison values were situated in a row along the top of a data table. In contrast, you would use VLOOKUP if your comparison values were located in a column to the left of the data you want to find, as they were in the previous task. Of the two functions, VLOOKUP is used far more frequently than HLOOKUP because of the nature of most data tables. The syntax for HLOOKUP is identical to that of VLOOKUP, except that you specify a row index number, referenced in a formula by Excel as row_index_num. This indicates the number of the row in the lookup table that contains the value you are looking for. Let's create a small lookup table on the right-hand side of our main data table. A few columns have been hidden in this worksheet to make viewing a little easier. So now we've got low HP, medium HP, and high HP in the top row of our lookup table. Next, we'll add wingding symbols as ratings for the 3 horsepower levels. 1 sad face for the low horsepower rating, 2 neutral faces for the medium rating, and 3 happy faces for the high horsepower rating. Now, let's add a new column to the right of the HP level column and call it HP rating. Then in cell L2, we'll enter the HLOOKUP function. This function will look for the value in cell K2, which in this case is medium HP, and it will look for it in the cell range from Y21 to AA22, which is our little lookup table, and it will return the answer it finds in row 2 of the table under medium HP and use an exact value. Note that we've used some absolute references in this formula too. Notice that what is returned is the text KK, so we need to format the cell using the Wingdings font. Now, when we double-click the fill handle, the whole column shows the HP rating symbols relevant to each row's HP level value. And we're done. Although VLOOKUP and HLOOKUP are regularly still used as the de facto functions for lookup references in Excel, there is a newer function called XLOOKUP. This version is only supported on Excel desktop versions from Excel for Microsoft 365 and on Excel for the web, as well as on Excel for iPad and iPhone and Excel for Android tablets and phones. XLOOKUP is an improved and combined version of VLOOKUP and HLOOKUP together. It can work in any direction, vertically or horizontally. It also uses separate lookup array and return array values, instead of a single table array and a column or row index number. In this video, we learned how to use the VLOOKUP and HLOOKUP functions in Excel to find and connect to data referenced in both vertical and horizontal lookup tables. In the videos coming up in the next lesson, we'll start to look at using pivot tables in Excel. Now that we've learned how to use the VLOOKUP and HLOOKUP functions, in this video we'll look at how to create and use pivot tables in Excel. We'll first look at how to format our data as a table, then how to create pivot tables and use fields in a pivot table to analyze data. And lastly, we'll see how to perform calculations in a pivot table. Having a worksheet full of informational data is all very well, but to really get some use out of it, we need to analyze it from different perspectives to find answers to questions related to the data. Now, we've already used features such as filters and formulas to draw mathematical and logical conclusions about our data. But not all questions can be answered easily using filters and formulas alone. In order to obtain usable and presentable insights into your data, you need something else. And that something else is pivot tables. Pivot tables provide a simple and quick way in spreadsheets to summarize and analyze data, to observe trends and patterns in your data, and to make comparisons of your data. A pivot table is dynamic, so as you change and add data to the original data set on which the pivot table is based, so the analysis and summary information changes too. A data analyst can use pivot tables to draw useful and relevant conclusions about and create insights into an organization's data in order to present those insights to interested parties within the company. Before you start to create a pivot table in Excel, it can be very helpful to first format your data as a table. The reason for this is not only to make it more organized and defined and to add table styles to your data, but primarily it makes it a lot easier when adding records to the dataset. In the car sales worksheet, let's first select any cell within the data, and then on the Home tab in the Styles group, choose Format as Table. Then choose a style from the gallery. Note that Excel automatically knows the boundaries of our data range, but we can change this if we need to. And ensure you select My Table Has Headers if indeed it does. After you click OK and the data has been formatted as a table, Note the filter drop-downs at the top of each column. These are automatically added when you format as a table. If we now scroll down to the bottom of the table and start adding another row of data for another vehicle, when you click Tab or Enter, note that it is automatically formatted and included as part of our table. Okay, now let's see how to create a basic pivot table and how to use fields to arrange data in a pivot table. Just before we do that, there are a few things you should use as a checklist to ensure your data is in a fit state to make a pivot table from. And these are: format your data as a table for best results. Ensure column headings are correct, and there is only one header row, as these column headings become the field names in a pivot table. Remove any blank rows and columns, and try to eliminate blank cells also. Ensure value fields are formatted as numbers and not text. Ensure date fields are formatted as dates and not text. In the worksheet, we can just select any cell in the table. Then, on the Insert tab, we click Pivot Table. Note that in the Select a Table or Range box, the table name, Table 1, is already entered for us. If we hadn't just formatted this data as a table, we would specify the cell range here instead. Under that, we need to decide whether we want to create the pivot table on a separate new blank worksheet or on this worksheet. A new worksheet is the default and is the most commonly used option. So, a new blank worksheet opens, displaying some basic pivot table instructions in the graphic on the left of the worksheet, and a pivot table fields pane on the right. You can rename the worksheet for the pivot table if you wish. To build the pivot table report, we need to add some fields from the top of the pivot table fields pane to one or more of the sections in the bottom part of the pane. For example, if we want to find out the total sales for each model of car, let's drag the manufacturer field to the rows section of the report, and then we'll drag the model field there too. But this isn't really the way we want it to look, so we'll drag the manufacturer field to appear at the top of the rows section above the model, which makes more sense with our data. Next, we'll add the price field to the column section, but again, that really isn't the way we want to view the data, so we'll drag price to the values section instead, which makes a lot more sense and looks a lot better. Next, we'll add the unit sales field to values too. So now we can see both the individual price for each model and the number of unit sales of each model. Let's add the vehicle type field to columns, but that doesn't seem very useful, so let's remove that field, which we can do in two ways, either by using the drop-down menu, or if we undo that, we can also do it by simply dragging the field out of the columns section, either to the left over the worksheet or to the top over the fields list above. Let's now look at how to perform a simple calculation in a pivot table. If we look at the sum of price column in our pivot table, we can see that the figures are formatted as general. So first, let's change the format of these figures to US currency. This can be done by modifying the value field settings for the field in the relevant section of the pivot table fields pane. We'll format the field as US dollars and show no decimal places. Next, we'll add a calculated field from the Pivot Table Analyze tab using the Fields, Items, and Sets button. We want this field to calculate the total sales for each model by multiplying the price by the number of unit sales. When we create and add this formula, it gets added to the Pivot Table Fields pane as a field called Total Model Sales. And we can change the format to make it US dollars again. A new column called Sum of Total Model Sales has now appeared in the pivot table in our worksheet. In row 5, we can see that there have been over $360 million of sales of the Acura Integra model. And in row 7, we can see that there has been over $1 billion in sales of the Acura TL model. In this video, we learned how to format data as a table, how to create a pivot table, and use fields to analyze data in a pivot table, and how to perform calculations using pivot table data. In the next video, we'll look at some other features of pivot tables. In this video, we will listen to several data professionals discuss their experience using pivot tables to analyze data. What are your experiences using pivot tables to analyze data?
My experience using pivot tables in Excel is extensive. I can use them all the time. The thing to keep in mind is that you can sum, average, and count easily. You can set it to group by so people can choose what the parameters are at the top. It's great if you've got a couple of thousand records all the way up to whatever Excel can handle. So a pivot table is just a real simple way of manipulation without having to do any actual querying or development language.
I once had a huge e-commerce sales data. I need to analyze the KPIs, including gross merchandise volume and take rate. However, I can only generate limited insights if I stay at a high level. With pivot tables, I was able to group the data in terms of countries, type of stores, type of products, which enable me to view the data and analyze the key KPIs at different levels of granularity.
I use pivot tables, and we use pivot tables in our firm, especially during audits, to assist us and help us to kind of drill down on the data. Because what a pivot table does is it helps you to take a large set of data and whittle it down to something that's meaningful. So in the case of audits, a client might have, $500,000 worth of maintenance and repair bills that are made up of 300 invoices. Well, we don't want to see every invoice for every dollar. We want to see the high dollar invoices. So we're going to use that pivot table to narrow it down to the invoices that actually are going to have the highest level of impact on the financial statement.
Much like Excel, pivot tables are a great way to understand your data quickly and effectively. Being able to just open up an Excel sheet, put it into a pivot table, drag and drop things in to get a sense of what the numbers look like, what the values are, really can help you get a good sense of the data in order to then start to build out something a little bit more robust. Being able to understand the fields, what they mean, what they look like, these are all things that can help you at the start of a project as you're looking to do your analysis.
Pivot tables are incredibly useful to get a quick view of your data and to look at multiple levels of your data in a very quick and clean way. It's just very, very easy to create a pivot table on a set of raw data, aggregate it by some level of interest, be it country, be it, country the user's from, be it the year the user joined, or anything else, be it something related to time. It's really good for quickly seeing and understanding some of the more high-level summaries that are hidden within your data.
Now that we've learned how to create and use pivot tables in Excel, in this video, we'll look at some other features that we can use with pivot tables, including recommended pivot tables, filters, slicers, and timelines. First, let's look at recommended pivot tables, which isn't exactly a feature as such. It's really more of a list of suggested different combinations of data that could be used when creating a pivot table. These recommendations are based on the data we select in the worksheet, and they are a great way to get started creating pivot tables if you don't have much experience with them yet. For example, in the Vehicle Toy Sales worksheet, if we select column B, which contains data about the quantity of items ordered, when we choose recommended pivot tables from the Insert tab, then we are presented with a list of potential data combinations related to the order quantity information. However, if we select column F, which contains order size information, then the recommended pivot table list changes to reflect that data. And if we select column E, which contains sales information, then the pivot tables recommended are related to sales data. Let's select the third one down, which is the sum of sales by territory, because that sounds like something we could get some useful insight from by presenting it in a pivot table. Note that the new worksheet is opened containing the recommended pivot table, and a new pane opens on the right called Pivot Table Fields. Let's rename the worksheet to something more meaningful. In the Pivot Table Fields pane, you can see that some fields have already been added to the rows and values areas. Although it's a recommended pivot table, we can still make it our own by adding more fields, for example. So let's add the product line item to the columns area using drag and drop. Now we have columns for each of the product lines in our pivot table, such as motorcycles, ships, and trains. In the pivot table, we can manually expand any field we want to view its contents. Here we can see that the order dates are located underneath the territory names in our pivot table. Note that this matches the order of the fields in the rows area of the Pivot Table Fields pane. We can manually collapse each of the fields too, but we also have the option of expanding all the fields at once and collapsing them all too. The next feature we will delve into is pivot table filtering. Pivot table filters work in much the same way as the standard filters we used earlier in the course. Note that we already have some inbuilt filtering in this pivot table. For example, the rows label header is a filter, and we can filter on any of the listed territories, such as Japan. Just like standard filters, it's very simple to clear a filter in a pivot table. We also have a column labels filter, allowing us to filter on any of the product line items in this pivot table. For example, we could show data only for the trains product. We also have the option of adding the product line field as a standard filter instead of a column heading by dragging it to the filters area in the Pivot Table Fields pane. And we can then use it as a standard filter as we have done earlier in this course. The filter also allows us to select multiple filter items, but because it's now being used as a standard filter rather than a column header, we can't see the split of the information on these two product lines. We just see a combined total. When we had the filter as a column header, the information on each product line was presented separately in each column. Let's display all the field totals again, and we'll drag the product line field back to the columns area where it was previously, so we can see the split of our different product lines in the pivot table. The next pivot table feature we will look at are slicers. Slicers are essentially on-screen graphical filter objects that enable you to filter your data using buttons. Slicers make it easy to perform quick filtering of your pivot table data, and they also display the current filter state, making it easier for you to know and see what data is currently being shown and which is being hidden by the filter. For example, if we remove the product line field from the pivot table by dragging it out of the Pivot Table Fields pane, and then from the Pivot Table Analyze tab, we click Insert Slicer, and then choose the territory field as our slicer, we can see that the slicer can be freely moved around anywhere on the worksheet, and it contains buttons for each of the territory names, such as EMEA, North America, and Japan. We can also select the Multi-Select button to filter on multiple territories if we wish. We can click the Clear Filter button to clear all the slicer filters. Let's add another slicer to our worksheet for the product line field. However, be sure to select a cell in the pivot table first, because if you don't, then the Insert Slicer button won't work. Note that slicers can also be added from the Filters group on the Insert tab, as well as from the Pivot Table Analyze tab. We'll select the product line field this time for our slicer and drag it near the top of the worksheet. As before, we can select only one slicer item, or we can turn on Multi-Select and choose several items to filter on in the slicer. Then let's clear the slicer filters. And now let's filter using both slicers. Note that when you use Multi-Select filtering, when you select an item, you are in fact filtering it out. That is, you are defining which items will not be displayed in the pivot table. This is the opposite behavior to when you were selecting single items in a slicer. So now we are displaying only classic cars, trains, and trucks and buses products for the EMEA and North America territories. Now let's clear those slicer filters and put the product line field back in the columns area of the pivot table, so it's ready for the next feature we will explore. And let's move these slicers out of the way further down the worksheet. The last useful feature for pivot tables we are going to look at is timelines. A timeline is another type of filter tool that enables you to filter specifically on date-related data in your pivot table. This is a much quicker and more effective way of dynamically filtering by date rather than having to create and adjust filters on your date columns. We can add a timeline for our pivot table either from the Pivot Table Analyze tab or from the Insert tab. Again, ensure you select any cell in the pivot table first. We'll select the Order Date field as our timeline filter. Then we can drag it up the worksheet and enlarge it. The default for this timeline is to display data by month, but you can also filter by days or by quarters. You can select a single quarter or you can select a range of quarters. In this case, we'll select 12 months between quarter 3 of 2003 and quarter 2 of 2004. You can use the Clear Filter button to clear a timeline filter. You can also filter by years. For example, here we have selected 2003 only. And you can combine slicers and timelines as filters in a pivot table. For example, here we can filter the slicers to display only data for trains in the EMEA and North America territories and only in the year 2003. And if we filter on the year 2004 instead, you'll see that there is no data being displayed, meaning that there were no sales of train products in 2004 in either the EMEA or the North American territories. Timelines and slicers have their own tabs in the ribbon when you select them, and their properties can be modified to change how they look and how they work. For example, let's change this timeline to a light green shade. And let's change this slicer to a nice orange color. And lastly, to remove a timeline or slicer, you can either select it and press the Delete key, or right-click it and choose Cut. In this video, we learned about some of the other features in Excel that we can use with pivot tables, namely recommended pivot tables, filters, slicers, and timelines.